Assalamualaikum and hi everyone. My name is Amir Hidayat Bin Othman. My student ID is 2019-229724. I am a mechanical engineering student at UiTM Shalam. Currently, I'm in semester 7, session 2022-2023. So, I'm taking final year project under supervised by Dr. Alias bin Muhammad Saman. So, in this video, I will be explaining my final year project, which is yield improvement for sand casting product using casting simulation tool. In this video, there will be 4 contents. Before we go further, we need to understand what is sand casting. Sand casting is a manufacturing process in which molten metal is poured into a mold that contains a cavity of the desired shape. So basically, this is an example how the mold looks like. So the top one is cope, the bottom one is drag. So inside this mold, it contains a cavity of any desired shape. So the process will allow some period of time to allow the molten metal to solidify. Same with other manufacturing process, sand casting also have several defects if the process is not handled properly. Therefore, the aim of my project is to improve the casting yield, which is the performance of the casting process. So, why casting yield is important? Casting yield is defined as the weight of the casting divided by the total amount of metal poured plus with the casting product and also with the gating system. A high percentage value of casting yield means that the overall performance of the casting process is efficient. Therefore, it can reduce the wastage of pouring metal, improve the product quality, reducing the casting defects, and also increase the productivity. So the problem statements are: the possibility of casting defect may occur without proper gating system. Number 2, determination of gating risering system. Number 3, optimum design of gating and risering may improve the casting yield. So the objectives of this project is to establish the gating and risering system, and then to evaluate the effectiveness of gating system, and lastly to propose the optimum casting yield. For the scope and limitations of this project, it will focus solely on improving the gating and risering system. The CATIA software will be used to create the 3D model, and Altair Inspire CAS software is the simulation tool that will be used to analyze the casting simulation. Next, we move on to the literature review. Lal Narayan Pandey said that the casting process is ideal because it permits the formation of streamlined, intricate, integral parts, strength parts, and rigidity obtainable by no other methods of operations, which mean that the product can only be produced by sand casting process only. Next, Nanda Gopal et al. Said that the design of gating system and riser is one of the major factors for improving the casting quality and yield. The well-designed gating system and riser results in reduced casting defects and increased yield, which means that the gating system needs to be designed properly. And last, for sand casting topic, is Shubham et al. Mentioned that casting defects can negatively impact the bottom line of foundry. A defect in the casting spoils the casting surface quality and mechanical properties. It is responsible for loss of profitability, quality level, and productivity of component, which means every manufacturer that use sand casting process should consider casting defect very seriously to produce a high quality product. For casting simulation topic, Malik et al. Stated that the simulation tool has flexibility of analyzing and visualizing in a color bar of mold filling and solidification processes, identifying critical locations and identifying casting defects such as microporosities and shrinkage porosities. Thus, it is important to simulate the product before the fabrication process. Even a case study done by Loha et al. Shows an increment 15.11% of the casting yield by modifying the gating system such as choke area, sprue shape, runner and in-gate. Thus, simulation gives better understanding on analyzing the performance of casting process. And for the last one, Priya et al. They managed to reduce the blowholes defect, reducing the percentage from 12.3% to 8.5%. They said blowholes is the most common defect occur in sand casting due to hotspot area. Hotspot means that an area that gets solidified last. Next, the methodology. So this is the flow chart of my final year project, starting off with literature review, understand the sand casting process, understand the yield improvement and so on, and then identify case study. What will be the product that will be casted, the material, the composition and so on. After identifying the material, next is to identify the gating system parameter, the gating ratio and how the configuration of the mold and what type of gating system. And then I do the 3D modeling using CATIA, and then design the gating and risering system in the simulation software. After that, I start to simulate the model to see the casting process. From the result, I will evaluate the casting yield. Therefore, there will be several iterations of simulation that will be done in order to achieve an improvement of casting yield, so that I can propose an optimum casting yield, which I will compare the first trial of the simulation with the improved simulation and see the difference between this casting yield. So I have mapped my flow chart with my objective. So the first 5 flow is my first objective, which is to establish gating and risering system. Next, my second objective is to evaluate the effectiveness of gating system that I have created. And for last objective is to propose an optimum casting yield. So the literature review is done. So for my case study is I'll choose brake drum as the product to be casted. The material is cast iron and the grade is FC250, which is Japan standard. The composition are 3.3% of carbon, 2.35% silicon, 0.55% manganese, 0.12% sulfur and 0.15% of phosphorus. And the density is 7.2 gram per centimeter cubic. This value will be used in the gating system calculation. Next, for gating system parameter. So the product will be in drag. So imagine this is a mold. This is the parting line. The product will sit at the bottom of the mold, which is known as top gating. Next is the gating ratio, which is ratio area for sprue to the total cross-sectional area of runner and then to the total cross-sectional area of gate. So for practical cast iron, the gating system has a gating ratio of 1 to 1.3 to 1.1. And last but not least, it is an unpressurized gating system, which is the choke is located at sprue. It is to reduce the turbulence of molten metal flow into the mold. After that, the product modeling. So picture on the left one is the 3D product I created using CATIA software, and on the right one is the simulation modeling. I use Altec Inspire Cast. And then as you can see at the simulation modeling, I managed to roughly insert the gating system such as sprue, runner, gate, riser and the core for the mold. Noted that this is just a rough gating system which doesn't involve with the calculation of gating system. And lastly, for the expected result, I should be able to calculate and design the gating system properly in order for me to achieve my objective, which is to propose an optimum casting yield. And this is the simulation that I am able to run to see the casting defect. And also, other than air entrapment and porosity defect, there are several other defects such as shrinkage. It can show the solidification time, filling process, and so on. So these results will be used to analyze the gating system that I have designed, and it will help me to achieve an improvement of the casting yield. So that is all for my final year project presentation. Thank you and Assalamualaikum.